Look, we all want to live longer, healthier lives, right? But the science of how we actually pull that off is shifting, and it's shifting fast. We're moving away from reactive medicine and heading straight toward proactive, data-driven geroscience. Today, we are diving deep into the data in this explainer to unpack exactly what drives our biology, and maybe more importantly, we're going to look at the hidden forces working both for and against it. Think about your last annual physical for a second. The crucial point we need to address right out of the gate is whether our standard medical exams are actually catching the root causes of chronic disease before it's too late. Usually, your doctor just tells you if your numbers are normal. But as we'll uncover today, normal definitely doesn't mean optimal when it comes to longevity. Honestly, by the time a standard test flags an issue, the underlying aging processes have probably been quietly accelerating in the background for years. So here is our roadmap for today. We'll kick things off with decoding longevity biomarkers and the roots of chronic disease. Then we'll explore AI and predictive health, move into metabolomics and cognitive decline, talk about taking back control, and finally, we'll wrap up with the structural healthcare paradox. All right, let's jump right into Section 1, Decoding Longevity Biomarkers, and uncover those hidden warning signs. Now, the absolute key difference we have to understand here is proactive geroscience versus reactive symptom management. Clinical biomarkers, well, those are your disease state indicators. They're what doctors use to make decisions once you're already sick. But preclinical biomarkers are totally different. They are your early warning system. Waiting around for clinical markers to change literally means the disease process is already well underway. Catching the trend early while you're still in that preclinical stage gives you vastly better odds of fixing it. And this is where it gets real. What's absolutely vital is keeping specific markers, like serum alkaline phosphatase, fasting glucose, or lymphocyte count, in their optimal ranges, not just hovering somewhere inside normal bounds. The data clearly shows that tracking inflammation markers, like high-sensitivity CRP or specific red blood cell metrics, correlates directly with your chronic disease risk, even if a doctor wouldn't traditionally treat them yet. Prolonged, non-optimal levels of these exact markers quietly build up your disease risk, which is exactly what eventually forces those standard clinical markers into the red zone. Moving right along to Section 2, the roots of chronic disease, taking a systems view. Because, let's face it, nothing in the human body happens in isolation. It's literally a domino effect. There's this massive cascade that kicks off with your gut microbiome and ectopic fat deposition in adipose tissue, which basically sparks a fire of inflammation. This inflammation, along with insulin resistance, cascades straight into the liver, causing non-alcoholic fatty liver disease. And from there, it heads right to the pancreas, leading to impaired insulin secretion and beta cell failure. It's just a massive web of metabolic dysfunction. And right in the middle of this mess is insulin resistance. It's a huge piece of the chronic disease puzzle, driven by interacting risk factors that we totally overlook until it's a major problem. It hits the muscles, the liver, and adipose tissue all at once. But what's really wild is how complex it is. For instance, insulin levels are heavily influenced by body mass index, sure. But get this, even with the exact same insulin level, someone with a low BMI might have an entirely different blood glucose risk profile than someone with a high BMI. It is deeply, deeply interconnected. So, how do we make sense of a web this complicated? That brings us to Section 3, AI and predictive health, modeling complex interactions. Because honestly, human brains just aren't wired to map dozens of fluctuating biomarkers over time. But AI totally is. AI tools like random forest models can take a massive laundry list of individual data points and actually predict your future risk of developing something like diabetes. By feeding large-scale public health data into these models, I'm talking inputs like waist circumference, triglycerides, serum HDL, white blood cell counts. The AI analyzes all those synergistic, complex roles. It looks at how triglycerides and insulin dance together, and then it outputs predictive levels for blood glucose and long-term metrics like HbA1c. It literally maps out the blueprint of aging and chronic disease. But hey, quick reality check. We have to remember the golden rule of data. Correlation is not causation. Since these aging-related biomarkers are so highly correlated with one another, it can actually limit their individual usefulness in a clinic. You really need massive data sets to separate the noise and find the true underlying mechanisms. There's a ton of variance out there, which is exactly why collecting de-identified, large-scale public data is an absolute game changer for statistical validation in precision care. Let's pivot a bit for Section 4, metabolomics and cognitive decline, and how we protect the brain. This is fascinating stuff. Tracking specific metabolic profiles gives us an incredibly clear picture of brain amyloid beta deposition and dementia progression, long before a standard memory test shows any impairment at all. The data points directly to specific metabolomic pathways, things like acylcarnitines, which shuttle fatty acids into your mitochondria, or phospholipids, which are tied to cellular stress. It even flags branched-chain amino acids linked to our old friend, insulin resistance. By the time someone actually sits down to take a cognitive assessment, their risk was already written in these metabolic pathways way in advance. Okay, we've seen the risks. Let's get practical. Section 5, taking back control and leaving the black box. How do we actually manage all this? I absolutely love this analogy because it hits the nail on the head. If you are eating right and hitting the gym, but you aren't measuring the internal results, you're basically just guessing in the dark. You're flying blind. Creating true awareness of your lifestyle requires actual, hard feedback. Tracking your specific preclinical biomarkers gives you tangible proof of what's working. It completely opens up the black box. So what are the actual levers we can pull? Well, these aren't just your standard vague health tips. These are targeted interventions to actively shift those longevity biomarkers into the optimal zones. We're talking about balancing macronutrients, really optimizing your carbs, fats, and protein, pumping up the fiber, ditching the fried foods, and using things like fish and olive oil to nail that omega-3 to omega-6 ratio. And it's not just diet. Stress, psychosocial factors, and optimized sleep play a massive, direct role in regulating that inflammation and insulin resistance we talked about earlier. But why is this so incredibly hard for most people to actually implement? Enter Section 6, the structural healthcare paradox and the macro forces at play. Here's the harsh reality presented in the source material. Our current system is trapped in a structural paradox. Healthcare systems that are fundamentally optimized for profit inherently lean toward managing the symptoms of chronic disease with long-term pharmaceuticals. They just aren't built to invest in root cause, preventative geroscience that would keep people out of the hospital in the first place. And then there's the trap of time poverty. Society constantly markets health as just a matter of simple individual willpower. Just try harder, right? But that completely ignores the intense economic demands that create a reality where fast, processed food and chronic sleep deprivation are literally the only options for so many people. It's a structural constraint that actively accelerates our biological aging, all while we're being told it's just a lack of discipline. 0. Yep. 0. Despite all our incredible scientific advancements, that is the exact number of years the absolute maximum human lifespan has actually extended. Now, sure, the average age of mortality across the population is way better today, mostly thanks to sanitation and emergency medicine. But the absolute maximum ceiling for how long a human can live, it hasn't budged. We're keeping people alive longer with chronic diseases, but we definitely aren't extending their healthy, optimal years. So here's the final thought I want to leave you with today. Armed with the knowledge of your own biomarkers, how are you going to step out of the black box and reclaim your time? The science of longevity is here, the AI tools to track it are getting better every day, and we know exactly which preclinical biomarkers to watch. The challenge for all of us now is using this framework to bypass the system that's just managing symptoms, so we can truly optimize our health span.